Welcome to this video lecture on the subject transmission lines and antennas. So in this lecture we are going to discuss about microstrip antennas. So microstrip antennas is shaped by simply etching out a piece of conducting material above a dielectric surface. So it is known as the microstrip or patch antenna. On the ground plane of this microstrip antenna, the dielectric material is mounted where this plane supports the entire structure. In addition, the excitation to this antenna can be provided with feed lines that are connected to the patch. So these antennas are considered low profile antennas used in microwave frequency applications above 100 MHz frequency. So antenna's microstrip patch can be selected to be rectangular, square, elliptical and circular for ease of analysis and fabrication. Some microstrip antennas do not utilize a dielectric substrate, but they are made with a metal patch that is mounted on a ground plane with dielectric spaces. Thus the resulting formation is less strong but its bandwidth is wider. So construction of microstrip antenna can be done with the help of an extremely thin metallic strip by arranging it on a ground plane in between a dielectric material. Here the dielectric material is a substrate used for separating the strip from the ground plane. Once this antenna is excited, then the generated waves in the dielectric undergo reflections and the energy emitted from the metal patch edges is very low. A microstrip works as whenever the current throughout a feed line arrives at the microstrip antenna, the electromagnetic waves are produced. So these waves from the patch will start radiating from the width side. When the strip thickness is very small, the waves produced in the substrate will get reflected through the strip edge. The constant strip structure along the length does not allow radiation emission. So the microstrip antenna's low radiating capability allows for covering only wave transmissions with small distances like stores, indoor locations or local offices. The specifications of microstrip antenna: its resonance frequency is 1.176 GHz, frequency range is from 2.26 GHz to 2.38 GHz, the substrate dielectric constant is 5.9, the dielectric substrate height is 635 micrometer, the feeding method is a microstrip line feed, the loss tangent is 0.0012. The conductor is silver, the thickness of the conductor is 25 micrometer and the bandwidth is plus or minus 10 GHz. And the types of microstrip antenna: the microstrip patch antenna, microstrip dipole antenna, printed slot antenna and microstrip traveling wave antenna. So these types of antennas are low profile where a metal patch is arranged at a ground level through a dielectric material in between comprising a strip or patch. So these are low size antennas with low radiation. So the patch is made with a conducting material like gold or copper. These types of antennas can be formed with the microstrip method by simply fabricating on a PCB. These antennas are used in microwave frequency application which have greater frequency than 100 MHz. Microstrip dipole antenna is a thin microstrip conductor and it is placed on the actual part of the substrate and it is covered totally with a metal on one face known as the ground plane. So these antennas are used in digital communication devices like computers and the nodes for wireless LAN. The width of this type of antenna is small, so it can be utilized at the entry point of the wireless LAN system. Next, a printed slot antenna. So printed slot antenna plays a key role in enhancing the antenna's bandwidth with radiation patterns in both directions. So the sensitivity is low as compared to normal antennas. Next, microstrip traveling wave antenna. Microstrip traveling wave antennas are mainly designed with long microstrip line by sufficient width for supporting the TE connectivity. So these types of microstrip antennas are designed in such a way that the major beam lies within any route from the broadside to end fire. Next is the feeding methods of microstrip antenna. So the contacting method and non-contacting feed. The contacting feed, the power is provided directly to the radiating element. So this can be done with a coaxial line or microstrip. So this type of feeding method is again classified into two types: microstrip feed and coaxial feed. In the non-contacting feed, the power is given to the radiating element from the feed line with electromagnetic coupling. So these methods are available in three types: aperture coupled, proximity coupled, and branch line feed. So this is the microstrip antenna radiation pattern. So it is radiation pattern is broad and less radiation power and narrow frequency bandwidth. By using these microstrip antennas, an array can be formed to have a superior directivity. Assessment questions. Thank you for listening.